Greetings to the jury members, and this is paper ID number 69. We have submitted our paper on the topic Study on Drowsiness Detection System using Deep Learning, presented to the 14th International Conference for Soft Computing and Pattern Recognition, taking place from December 14 to 16, 2022. The authors of the paper are Agilandeeshwari L, Associate Professor, Site VIT Vellore, and Nivetha S, Student MTech Software Engineering, Site VIT Vellore. Tirthankar Chakraborty, Student MTech Software Engineering, Site VIT Vellore. Vikash, Student MTech Software Engineering, Site VIT Vellore. The abstract of a paper. The primary goal of this study is to detect the drowsiness levels of drivers to make roads safer for people to ride on. People should be aware that to reach their home safely, they must be at least awake. Human tiredness at times becomes a severe problem that may hamper the protection of other people using the road. In more than 200 key investigations finished between 2000 and 2010, nearly every fifth instance had driver wariness as a basis deciding factor or finding as part of the inquiry. Drowsiness driving causes 21% of all fatal collisions. About 168 million adult drivers, which are over 60% of all drivers, have driven while fatigued in the previous year. In this paper, we present a detailed study on deep learning models, machine learning models, fuzzy models for drowsiness detection to alert drivers and help them avoid accidents. In this paper, we also conclude which model is best suited for the drowsiness detection system. As we move on for the introduction, according to the World Health Organization study, approximately 1.25 million people die each year because of road accidents. According to the report by Ministry of Road Transport and Highways published in the year 2019, the number of deaths due to road accidents was 15,231 in India. To combat this drowsiness, detection and monitoring systems were proposed and built. Most of these methods use one of the three techniques to detect drowsiness levels, that is, the psychological behavior, behavioral methods, and the vehicular based techniques. Some hybrid techniques, which combine more than one technique, have also been suggested to improve the accuracy of the prediction. In this article, we present an extensive review of the existing drowsiness systems, models using machine learning, deep learning, and fuzzy logic based and hybrid models. So as we move on to the general architecture, this is the general architecture followed by most of the detection systems present existing in the world. That is like there's a camera that takes video or image input while the driver is driving, which is fitted in front of him. Then the image or the data taken from the camera is sent for the image pre-processing. The pre-processed images then further go for face detection where the facial landmarks are extracted. From those facial landmarks only eye landmarks are extracted, and using the eye landmarks, calculating the EAR, that is eye aspect ratio, it is used as a classification if drowsy or not. It is sent to the classification system. If it is drowsy, then the alarm rings. If it is not drowsy, again it goes for the further input taking by the system. Image acquisition, as of now, the image dataset has been taken from the Kaggle, consisting of images of eyes categorized as open, closed, left, and right. The image dataset also contains collection of infrared photos, which was taken both in low light and high light resolutions and under varied lighting situations using multiple cameras. The attributes taken for the system are the eye aspect ratio and the mouth aspect ratio. Image enhancement. The data collected from the source has so much noisy data and unclear images, which is unfit for usage. Therefore, images are undergoing a process of image enhancement to be used in the system with clarity and precision. The following techniques have been used. Gaussian blur has been used to remove noisy data, and resizing image to a standard of 100 by 100 pixels for uniformity. Then, as we move on, we find a region of interest for a project. The region of interest are the mouth coordinates and the eye coordinates. Eye coordinates, it is calculated by eye aspect ratio, mouth coordinates using mouth aspect ratio. So image segmentation and fragmentation. The geometrical characteristics of eye, mouth, and nose are computed using the feature-based or analytic technique. The feature vector is in this illustration is made up of faces, contour, and the location of various facial characteristics. Typically, feature points are selected for effective extraction processes. Geometric features present the shape and positions of the face components, which are extracted to build a feature vector, and the location of those points are utilized to compute the geometrical connections. Next, the classifications. In this classification, we have classified a literature survey based on the models they have used. We have divided into mainly four categories, that is machine learning model techniques, deep learning model techniques, fuzzy based logic techniques, and the hybrid systems. So first let us get into the machine learning based techniques. So here are the few references for the machine learning techniques or literature review. In machine learning techniques, mostly they have used centerface algorithm or a hard classifier algorithm for taking the coordinates of the system. Mostly accuracy is good, and landmark, and the advantages is that they use the landmark as the algorithm to find the drowsiness of the state, and the data set will be mostly of images or video data set. Then, as a conclusion of this machine learning techniques of the literature survey, we find out that techniques such as logistic regression, naive Bayes, KNN, decision tree, and random forest have been used to detect drowsiness levels in drivers. And the model's accuracy ranged from 64 to 96%, with the random forest emerging as the successful algorithm, and SVM hybrid emerging as the best in recent times with the highest of the accuracy. So this is the comparison of all the machine learning based algorithms using different techniques, that is light framework, EEG, electrocephalograms, and FPGA based random forest, and SVM hybrid. Next, as we move on, is the deep learning techniques. In deep learning techniques, accuracy has been improved, and like convolution neural networks have been successfully used to detect drowsiness in drivers. A commonality has been discovered in steps that use extracting features from video frames, followed by normalization of the features, followed by the CNN model to classify and predict the drowsiness observed in such a system. ResNet 50, VGG16, and Inception V3 architectures with ReLU activation function are used along with specialized image processing libraries such as OpenCV and DLIM. Deep learning techniques utilized to determine drowsiness levels in drivers are LSTM, RNN, and transfer learning, which require the utilization of special training models of different sizes. It has been found that deep learning techniques have gotten higher accuracies, and the knowledge of distillation technique, in which two separate CNN models are used instead of a cumbersome method, has provided more accuracy. So this is a comparison of all the deep learning techniques and the percentage accuracy obtained from the models. This graph is of the testing and training loss, training data accuracy using LBP, and this is the other one is the testing and training model loss of LBP. Since Next is the fuzzy based techniques. In fuzzy based techniques, they have used EOG linear SVM to get the image processing usually methods, and to make highly accurate predictions, fuzzy logic techniques using MATLAB libraries were used. This technique has also been seen to be effective in cases where the drivers have been wearing glasses. Next, as we move on, is the hybrid system techniques. In hybrid system techniques, they have combined CNN and BiLSTM. The accuracy is really very high compared to the next other of the methods, and this is the overall comparison between all the methods such as machine learning, deep learning, fuzzy, and hybrid. Like as of now, only LBP has got the highest accuracy than hybrid systems. Next, we move on to validation and testing. In this article, we have explained various metrics used in various research papers. All papers use the same metrics, that is accuracy, timeliness, mean absolute deviation, um, mouth aspect ratio and eye aspect ratio. Accuracies NNNs, which provide improved classification accuracy at the expense of increased computing complexity, has gained popularity as a reliable alternative to machine learning techniques in recent years. And eye aspect ratio is the number of eye blinks has been calculated by calculating the EAR, and mouth aspect ratio is the length and width of the mouth. MIR will be higher than idle state if the person is yawning, hence detecting the drowsiness of the driver. Next, the challenges and issues we found from the various literature survey papers are that large models have a longer computation time and slightly more expensive components, hard to deploy on a large scale and intrusive for psychological methods. The accuracy of the model decreases when the glasses are worn. The detection level decreases in dark condition. Vehicular vibration might affect the accuracy levels. The accuracy may be affected by distance from the setup. Extraneous noise may cause reading to be distorted and false positive due to blinking. And the conclusion, and finally, with the conclusion and the future work, the first suggested method combines a convolutional neural network with a recurrent neural network to create a model based on deep learning for the estimate of the driver state of fatigue. The second method employs deep learning and artificial intelligence to pre-process the data before deploying the fuzzy inference system to calculate the amount of weariness, but the second method seems effective. In future, we can incorporate inception v3 layers to increase accuracy of the model using CNN and OpenCV. To demonstrate the generalizability of the constructed model, it can also be tested on large datasets with more samples of eye conditions. Finally, thank you for giving this opportunity to present our paper, and we will be looking forward for your response. Thank you.